Let us discuss a question on Rankine cycle. So let's draw a Rankine cycle in a TS diagram, and here we are talking about the process that take place in a turbine. So what we do is, now here you have, this is the constant pressure line. Okay, so we have three pressures involved here. Okay, so yeah, I'm just drawing a three pressure constant pressure line. So 15 MPa. So at the high pressure turbine, 15 MPa, now at 15 MPa 600 degrees Celsius, it's a superheated degree, so it's here. Okay, somewhere here, 15 MPa superheated degree Celsius. So now what he says is that it's condensed to 4 MPa. Okay, so I mean, let's draw 4 MPa somewhere like this. Okay, so it's condensed to 4 MPa and then again reheated. These are all constant pressure lines. So okay, these are all. So let's say this is 15 MPa. So at 15 MPa, which enters it, the steam enters the high pressure turbine. It is condensed. I mean, it does, so the steam does some work, so pressure decreases, and the reheating now occurs at 4 MPa. So at 4 MPa, it comes here. Now we do reheating. So reheating is again done at the constant pressure, so it will follow a constant pressure heat line. So this is 4 MPa pressure line. So it does goes to this until a point where, remember, this is a very important line, reheated to the inlet temperature of the high pressure tank. So it is reheated till the temperature which was the original temperature where it entered high pressure turbine. So this is 600 degree Celsius. Okay, so it is again heated to this. Now it is condensed. So now it is condensed. So now, though I mean, the diagram we have drawn like this. So now it is condensed. So let's draw it like this. Okay, this is again another constant pressure line. Okay, this is entropy. So it is condensed. Okay, till this point, and this pressure is basically 10 kPa, so very small, I mean, condenser pressure. Okay, so this is basically the process that take place. This process take place in a high pressure turbine. The right side process take place in a low pressure turbine. So at the end, whether we have moisture or not, that is the whole purpose of this problem. Generally, why we have two-stage turbines? To avoid moisture at the end, because if you have moisture at the end where it enters the condenser, if you have moisture, and because of the low pressure, there is a chance there's a cavitation may happen, and even the moisture content will try to destroy the blade and such that. So we want very less moisture content here. That's why we have a two-stage turbine. Reheating is done. Okay, so now our question is, what is the moisture content at the exhaust of low pressure turbine? Okay, so here what is the moisture content we need to find out. So what we do is we take the low pressure turbine process which take place in the low pressure turbine. So this is a constant enthalpy process, because we assume that turbine efficiencies are not given, so we assume that it's a constant entropy process. So constant entropy process. So entropy at 4 MPa and 600 degrees Celsius is equal to entropy at 10 kPa, right? So entropy at 4 MPa 600 degrees superheated entropy, which is given in the first table, which is this 7.3688. 7.3688 is the entropy. That entropy remains same at here. Now here, because we have, assuming that we have both liquid and vapor content, so we have both SF and SFG. So we write SF plus X into SFG, and SF and SFG we need to find out at 10 kPa. So 10 kPa, assuming that it's a mixture, so SF is given as 0.6492 and SFG 7 points, so 0.6492 and 7 plus 7.5. so remember that because this is less than 7.5, so obviously the highest here, the entropy here is 7.5 and this is 7.3, so there has to be some liquid content. So 7.5, So into x, right, into x. So now x from this equation we can find out. 7.3688 is equal to 0.6492 plus x into 7.5. So x from this equation we get 0.8958. So this is the dryness fraction. Okay, and so the moisture content will be 1 minus x of this, so 1 minus 0.8958. that means mass of vapor by mass of air is 89%, but mass of liquid is what is we need to find out the moisture content. So that is 0.1042, and that is in percentage it is 10.42, because we need to find out in percentage. So 10.42 is the liquid content or the moisture content. Thank you.